All right, last class we did factoring. Just leave it up here. All right, so looking at w squared plus 6v plus 6 plus w squared v. So, we talked about whenever you have four or more terms, we would factor by grouping. And you would also start off with the first two and the second two and see if you can factor out a GCF. But when we look at this first two and the second two, there's nothing in common that we can factor out of each. Like this w squared and this 6v do not have anything in common. The 6 and the w squared v has nothing in common. So what you want to do is couple together the terms that have something in common. So we won't use this grouping, but let's rearrange our terms. And with addition, everything's commutative. So you can rearrange the terms, move your terms around. Just remember that whatever's positive needs to stay positive, whatever's negative needs to stay negative. So let's put the w squared and the w squared v together. And the 6 and the 6v. All of our terms are positive in this case, so it doesn't matter, what order, as long as it doesn't matter, if our signs are concerned, that's what we'll say. But let's just say if 6v was negative, then that means 6v would have to be negative here as well. So that's what I mean by if it's positive, make sure it stays positive. If it's negative, make sure it stays negative. All right, so now I have a v squared that's in common with each term here. Factor that out. That will be 1 plus v. And in the next one, I have a 6 that's in common with both. So I factor that out. And that will be 1 plus v. And remember, when we get to this point, what's in the parentheses have to be exactly the same, or you cannot go any further. We do have that. So there's 1 plus v, w squared plus 6 is what's left. And that's what would go in our parentheses.
I couldn't see that to save my life yesterday.
Well, it's all good, man. It's all good. Any questions before we go anywhere else? Go back to, I believe we were factoring trinomials. All right. As a matter of fact, let me go back to 6.5. And I think this is, let me see what section this is. 6.7 was greatest common factor. Factoring trinomials, a 6.10. Okay. All right. We're going to factor in trinomials. Let me get my examples. I had them out. Turn the page. And now I lost my page. All right, so let's make sure we at least review where we went or where we were last class. And that's factoring when your leading coefficient is 1, when we don't have anything in front of that squared variable. So remember we said we would go ahead and set up our 2 sets of parentheses. Look at the back sign first. If your back sign is positive, that means the signs in your parentheses will be the same. And this front sign tells us which sign to use. So that means both of our signs will be negative. All right. So right here, that w squared comes from w times w. So each one of your first terms in your parentheses will multiply together to give you a first term in your trinomial. And then your back term, we have 50. So we need to look at all of our factors of 50 and see what 2 numbers multiply to give us 50. But because of our signs being the same, these 2 numbers have to add together to give us 15. So if you look at your choices, we got 1 times 50, 2 times 25, and 5 times 10. And of course, it would be 5 and 10, and that would be our factorization. Questions?
I got a question. If we put the 10 first and the 5, will we still come up with the same answer?
Yep.
Okay.
Talking about like that, right?
Yes.
Yep, that's fine. All right, let's look at one more without a 1 in front. Choose one with different signs. All right, here, x squared plus 4x minus 45. And the reason why I want to emphasize this whole seeing the signs before you actually start the factor thing. Okay, I did. Yeah, I did press record, just making sure. Only reason I want to emphasize the seeing the signs before you start the factor thing, because that always holds true no matter what's going on with the numbers. If you have a trinomial and you look at the back sign, you know, everything's in descending order and everything is where it's set up, where it needs to be. That back sign lets you know that your signs in your parentheses, in this case, should be different. So you can write plus or minus. Minus plus doesn't matter because we haven't put anything else in there. Once again, x squared is a result of x times x. Now we need the factors of 45. That because our signs are different, they need to subtract from each other to give us 4 in that middle. So you're talking about 1 times 45, 5 times 9. I think we do what, 3 times 15. But of course, the one we would need is the 5 and 9. And then the greater number will take on that positive sign. So that would be a positive 9 and a minus 5. All right. Questions on that? All right. All right. So let's throw a number in front. Oh, let's do this as well. do one more, and then we'll put a number in front. All right, so negative c squared minus 22cd minus 60d squared. Remember last class, before we close out, we mentioned factor out GCF. So our GCF, we look at each one of these terms, would be 2. And not just 2, we can actually factor out negative 2. All right. So we pull the negative 2 out front. I think I'll stay back. So that'd be c squared plus 11cd plus 30 d squared. Any questions so far? All right, so sign in the back tells me both of my signs should be the same. Sign up front tells me what signs to use, so that means I should have plus in both cases. Then 2 front terms, c times c, give me c squared. And then in the back, need our factors of 30, 1 times 30, 2 times 15, 3 times 10, 5 times 6. All right, and the only reason I'm going through all of them, and I know you guys see that 6 plus 5 will give me 11. This is the thought process you have to go through, especially once we put a number out front. You want to look at all of your possibilities. Sometimes we forget to use all of the possibilities when we're looking at trying to factor. So just getting you in that mindset. So we need the terms or the factors of 30 that will add together to give us 11 because our signs are the same. And that will be 5 and 6, but don't forget the fact that we have a D back here too. So it's going to be 5D and 6D. And that would be your whole factorization or complete factorization. All right. Questions.
Professor,
Yes, sir.
I didn't know if your audio was out.
Yeah, I had an infiltrator. Had to silence my mute. I had to mute my button real quick. 3-year-old infiltrator. All right, so factoring trinomials when a is not equal to 1. And don't forget when we're talking about trinomials and a squared plus bx plus c. So, and then when we move forward, I think, yep, in the next chapter, we'll be using that format as well. So when they mention a is what's in front of your squared variable. B is what's in front of your variable that's not squared. That's normally called the linear variable. And then C is the constant, the one that's not attached to a variable at all. All right. So let's look at 2x squared plus 7x plus 6. All right. So now there are a couple different ways that you can go about factoring these trinomials. I normally just teach factoring by trial and error because that really helps you if you stick to learning that process. It really helps you see the ins and outs of factoring. And then once you become, proficient at it, you will start to see things that you don't have to do and don't have to do, and it becomes less about trial and error and really just about you knowing certain things that has to happen and won't have to happen because of your practice. So set up your parentheses. You always start off with what you know has to happen. That's the easiest way to do it. So in other words, what we know for a fact is that my back sign is positive, so my signs need to be the same. And this one tells us which sign to use, so both of my signs have to be positive. All right. Now remember before, all we had was x squared, so x times x gave us x squared. But now that we have a 2 here, just like we had to consider the factors of the back term, we have to consider the factors of this term, which would be 1 times 2. So the good thing about that is there's only one way to get 2, which is 2x times x. That has to happen. There's no other way to get a 2. All right, 1 times 2. Any problem so far? All right. So now in the back, I have options. I have 1 times 6 and 2 times 3. All right. So now, when you go about factoring, remember what has to happen is that this times this. Let me go with a different color. My purple. This times this times this times this, and this times this. The only one we know for a fact that's going to work is the 2x squared, because 2x times x gives me x squared. Now, when I put either 1 times 6 or 2 times 3 in the back, it does not have to work out and give me that 7x in the middle. And that's the part that we have to check. So in other words, if I were to put 2 here and 3 here, 2x times x is 2x squared, 2x times 3 is 6x. Then here 2 times x is 2x, 2 times 3 is 6. So you notice by using the factors, I'm going to get my outside terms. It's the middle that I need to check. And you see here, we don't get 7x when we add those together, we get 8x. So that's not the correct factorization. There's only going to be one correct factorization for your trinomial. So what you can do is say, okay, well, let me switch my terms. If I have 2x, because my numbers are fine, I get the 2x squared on the outside and the 6 on the outside. I need to get that 7 in the middle. So if I switch and say 2x plus 3, x plus 2, and then do my FOIL out again, 2x times x is 2x squared. Here I get 4x, 3x, and then 6 in the back. Add my terms together. And now I get 2x squared plus 7x plus 6. So this is the correct factorization. All right. Questions before we do another one?
So if we would have went with 6-1, we would have been wrong.
Yes, sir. But you would have saw it if you would have checked.
Gotcha.
So there's really no reason to get the answer wrong unless you're not comfortable with multiplying it out, because once you choose that factorization, you can check it by multiplying it out, and then you'll see whether your answer is right or wrong. All right, so let's look at 13y minus 6 plus 8y squared. I would suggest rearrange terms in descending order. All right. So it'd be 8y squared plus 13y minus 6. Remember, your order, whether it's descending or ascending, is dependent upon the exponent on your variable. So that's why I have 8y squared, then 13y to the first power, and then minus 6 with no y at all. Set up your parentheses, back sign means my signs are going to be different, and the greater combination needs to be given to that plus sign. All right, so looking at our choices, 1 times 8, 2 times 4. Choices here, 1 times 6, 2 times 3. All right. We're trying to get 13 in the middle. And don't forget, our signs have to, not our signs, our numbers have to subtract from each other to get the 13 in the middle, because we have different signs. All right. So let's see what we can do. Oh, let's try some stuff out before I throw the answer out there. So we can do 2y, 4y. 1 times 6. And so if you think that's a legit option, you would make sure you check. And then, so let's do it like that. I'm going to get 8y squared here, negative 12y, 4y, and there's negative 6. So once again, I just wanted to show you, if you're choosing the right factors, you're going to get your outside terms. So don't get comfortable with that. Some people, they try to find a shortcut to this, and so they're happy that they got the outside terms, but then they never go back and check here. And we see in the middle, when we add those together, we would actually get negative 8y. So you have to be careful. When you choosing your values, you do want to be strategic. We know we need to get 13. So I would be thinking about, because remember, these numbers have to multiply, these numbers have to multiply. Let's do it like this. These two and these two will multiply to give us that middle. Now you should say it's the smiley face. We know it's the outside terms and the middle terms that multiply to give us that middle combination. So when I'm looking at this, I'm thinking to myself, how can I get something close to 13 in the middle? And I know 8 times 2 will give me 16. So I would try it. Let's see what will work out. So here I have 8y plus 3 and y minus 2. And once again, like I said, the method is called factoring by trial and error. But the more you do it, the less it becomes trial and error. So it's all about practice and repetition, just like all other math practices. So 8y times y is 8y squared. 8y times negative 2 is negative 16y. 3 times y is 3y. And then I have negative 6. Now when I combine my like terms in the middle, 8y squared minus 13y minus 6. All right. So notice that we have a negative 13y, but we needed a positive 13y. If that's ever the case, just switch signs. So that'll be 8y minus 3, y plus 2. All right, so another example, 10x squared plus 11x plus 1. Sign should be both positive. Factors of 1, just 1 times 1. So you just go ahead and throw that back there. Factors of 10, 1 times 10, 2 times 5. All right, so remember what we're trying to do is to get 11 in the middle. If I were to use 2x and 5x, that would not work for us, because you know when you go to do your multiplication, yes, we'll get 10x squared first, then that'll be 2x, and we get 5x, and then 1 in the back. Once again, notice we get our outside terms, but the middle is not going to work for us. So our best shot would be to do 10x plus 1, and then 1x plus 1. If I fold this out, 10x squared, 10x, 1x, and then 1, and you see 10x plus 1x is 11x. So this would be our factorization. All right, questions? All right, before I go to the next thing, let me see if they want you guys to, they should, just want to make sure though, if they lean on the difference of squares and all the good stuff like that. Yeah. All right. Okay. I think this section is. So try those trinomials out. If you have any issues with them, feel free to shoot me that email and I can help you out. The next section is factoring special products. All right, so the difference of squares. X squared minus y squared is equal to x plus y times x, should be minus y. X plus y times x minus y. So if I have a squared minus 25, what this is saying is that if I have two perfect squares being subtracted from each other, difference means subtraction. A squared is just a times itself twice. 25 is 5 squared. If you have that scenario, then you take what's being squared and write it in your parentheses with a plus minus in between. All right. If I have 49s squared minus 4t to the fourth, so 49 is 7 squared, but we have an s in there, minus 4t to the fourth, so that's 2t squared. All right. Since we have that, that means I can rewrite it as 7s plus 2t squared, 7s minus 2t squared. All right. Questions before we look at the next one? All right. So for the next one, 18w squared z minus 2z. Remember I said always look for the GCF first, if possible. Factor it out. Here I can factor out 2z. So that'd be 9w squared minus 1. Now I can use the difference of squares. That's 3w squared. And then 1 is just 1 squared. So my complete factorization, that 2z is a part of your factorization. 3w plus 1, 3w minus 1. Questions so far? All right, so the sum of squares is prime. It cannot be factored. So be careful with that, because a lot of times people will make up stuff that does not work. So in other words, if you see a squared, remember before we had a squared minus 25, a squared plus 25 is prime. Remember, if you cannot do anything with it, then it is considered prime. Now, if I could factor out a GCF, that's not prime. I factored out a greatest common factor. But if there's nothing that can be done, that expression is considered prime. So p squared minus 9 is p plus 3, p minus 3. Those are perfect squares. P times p, and then 9 is 3 times 3. But p squared plus 9, once again, is prime. Questions? Any questions? Oh, not 91, 81. All right, w to the fourth minus 81. So w to the fourth is w squared, squared. 9 is 9, I mean not 9, 81 is 9 squared. So that's w squared plus 9, w squared minus 9. Difference of squares. And then notice we have the difference of squares again. And both of these, that's w squared, and this is 3 squared. So keep in mind, this cannot be factored, so we just bring it down. That's a sum of squares, cannot factor that. And then the next set would be x plus 3, x minus 3. So it comes from that set of parentheses. All right. Questions? We'll talk about it later. All right. A few other formulas. The difference of cubes. All right, so difference of cubes, x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. Sum of cubes, x cubed plus y cubed, that's x plus y, x squared minus xy plus y squared. So before we were looking for perfect squares. Here we'll be looking for perfect cubes. All right. So first example like this, we have w cubed plus 64. W cubed is w times itself 3 times. 64 is a perfect square, but it's also a perfect cube. And that's 4 times itself 3 times. All right. So we look at the formula. Sum of cubes says that if we have, and I'll just rewrite it down here. All right, so that W, we're plugging in where X is, and that 4, we're going to plug in where Y is. I guess I'll get back. So that's going to be W plus 4, W squared minus W times 4, then 4 squared. So make sure we're okay with the substitution. Our first term was W, second term was 4. Plug in the 4 where we saw X. Plug in W where we saw X. Plug in 4 where we saw Y. All right, so now we can simplify. W plus 4. W squared is just W squared. Now put a 3. W times 4 is 4W. And then 4 squared is 16. All right. Questions? All right. Here we have 27p cubed minus 1000q cubed. Once again, we're looking for perfect cubes. So 3 is 27 cubed, so that'd be 3p. 1000 is 10 cubed, so it's 10q. So just remember that if the whole term isn't a perfect cube, then you cannot use this formula. So keep that in mind. All right, so looking at the formula, x cubed minus y cubed is x minus y, x squared plus xy plus y squared. So 3p goes in where you see x, 10p goes in where you see y. So it's 3p minus 10q, x minus y, 3p squared plus 3p times 10q plus 10q squared. Three p minus 10q stays the same. 3p squared. So you got to square both of those. That'll be 9p squared. 3 times 10 is 30. PQ. Then 10 squared is 100 Q squared. And that will be a factorization. All right, let's do at least one more like this. 125a cubed plus 1. So it's going to be 5a, and then 1 is always a perfect cube or perfect square. So that'll work for you. Just rewriting the formula down here. So once again, this first cube root is going in for x. Second one is going in for y. I don't know why I put that extra parentheses. All right. So that's going to be 5a plus 1, 5a squared, 5a times 1, and then 1 squared. A plus 1, 25a squared, 5a times 1 is 5a, and there should be a plus back here, and that's plus 1. Questions? Any questions? All right, here we have our 4 terms again. So we're going to factor by grouping. So when we set up our groupings, don't forget this middle term does not need to be separated from that minus sign. So we include it inside of the second set of grouping symbols. Factor out your GCF. Gonna be 4x squared. That'll leave you x plus 1. The next one will factor out negative 25. That'll leave us with x plus 1 as well. X plus 1s, bring them out front. What's left in the parentheses is the 4x squared minus 25. Yep, well, that's a difference of squares, so we're not done factoring yet. This is 2x squared. 25, of course, is 5 squared. So that first parenthesis stays the same. The second one breaks down into 2x plus 5, 2x minus 5. That would be your complete factorization. Questions, questions, questions. As a matter of fact, I'll write this. I'm going to write that over, so just put the title here. All right, so the next set, you don't need formulas for them, even though they do have relationships that you could use. But normally I don't give them because you guys have enough formulas to deal with. So if you just treat these the same way you would the regular trinomials, these are called perfect square trinomials because the first term is a perfect square. First term perfect square and the back term is a perfect square. So both of your signs are going to be the same, and the front one tell you which one to use. So both of your signs will be positive. Use x and x to give me x squared, and then 7 and 7 in the back to give me 49. That's 7 squared, and this is x squared. And that's your factorization. If you were to multiply them out, 7 times 7 give you 49. 7 plus 7 will give you that 14 in the middle. So whenever you have a perfect square trinomial, this is the scenario that you have. Same thing here. 25y squared minus 20y plus 4. It's a trinomial, so set up your parentheses. Back sign is positive. Front sign is negative, so that means both of my signs should be negative. 4 is 2 squared. 25, it was not just 25, it's 25y squared, right? That'll be 5y squared. So try out those perfect squares. And always do your check to make sure that it comes out to give you what you originally had. So if we were to fall that out, 5 times 2 and 5 times 2 in the middle will give you that 10 plus 10, which is 20. And that's our factorization. So that's what it means to have a perfect square trinomial. But if you apply what we did to factor out our trinomials, even if they weren't perfect squares, you don't have to necessarily worry about the formula. I didn't write this. Another way of writing this is x plus 7 squared. Or you can write this as 5y minus 2 squared. Either one of those are fine. All right. Questions on anything? So we have one more section to go before we close out this unit. And make sure in this class, okay. So next class, first thing I'll do is ask you if you have any questions, and then we will do that last section. Last section is on factoring as well. We're just using factoring in order to solve equations. So questions, concerns, comments?
Yeah. So, Professor, is there any way, like, I'm ready to take the test, but I don't know what's going on with it anymore.
Oh, he's still now. Are you the one who emailed?
Yeah, that was me.
Now, did you get my email that I sent to you?
Yeah, I sent one back. Yeah, I got it.
Okay, let me see. Well, I'll talk to you. Let's close out the class, and then I'll talk to you before we close out. I mean, before I close you out. But any questions, concerns about class before we let everybody out for the weekend? Everybody good? Everybody straight? Okay.
All straight.
All right. So everyone take care. Have a great weekend. Be safe. I will see you on next class.